Uh, Welcome for our tech talk today. Uh, we are conducting our tech talk for the yeah. So we have been conducting this tech talk for the last year. Now we are confident enough that we can go live on this. So we chose to go live starting from today. So as the first live broadcast tech talk, uh, Thamal will be talking about unlocking the power of AWS Lambda. So I welcome all of you for those who are attending here and also those who are attending to this session online. So Tamal, over to you. Yeah.
Okay, thank you, Sandhu. First of all, I would like to warmly welcome you all, those who are joining online and joining on in person here. So, yeah, let's get started. As a start, I'll introduce myself. I'm Thamal Dilanka, a software engineer at Digis Global. So, let's see what we are going to cover today. Right. First of all, I will introduce the AWS Lambda, brief introduction about the service, and then we will discuss about core component of AWS Lambda, and then we will create a simple serverless API with AWS Lambda and API gateway. So then we will discuss about essential concept you must know about AWS Lambda service in order to use it in production use cases. So moving on, yeah. Uh, what is AWS Lambda? The main question. So AWS Lambda is a serverless event-driven compute service, of course, offered by Amazon Web Services. So in here, I want to highlight two keywords. First one is serverless. Uh, if you want to run some code in your anywhere, you want to make accessible to others, you have to deploy it. For that you have to have a server, but in here it says serverless, because actually there is a server that running your application, but we don't care about server provisioning, managing and scaling. So if anyone don't know what server provisioning is, that is the process where we setting up servers. So we have to give, even in the cloud environment, we have to give the CPU allocation and memory allocation. Those kind of things we have to set up manually. So this all the things will be in serverless. This all the things will be handled by the cloud provider. So that's what serverless means. The next one is it is a event driven service. What event driven is, AWS provide a function, right? We call it as a AWS Lambda function. So if it is a function, there should be a way to invoke that. We call it as in AWS Lambda, we call it as a trigger. So there can be mainly two types of triggers for Lambda. First one is HTTP API request. We can make a request to Lambda function, or else we can have an event from the provider. So I will discuss what are the providers are. There are many of providers in AWS services. So for now, these are the two main triggers that we can have for the AWS Lambda. Okay, moving on. So now I hope you all clear about the introduction uh, for the to the Lambda function. Okay, so the next question is, why AWS Lambda? Why do we need this kind of service? The first thing is cost effectiveness. Uh, in AWS Lambda, it is a pay per use model. Uh, when you are not using the function, when it's not get invoked, it will won't be charged from you. Otherwise, you have if you have run it in a server, it cannot be done. It will charge for the idle time as well. So, and the no server maintenance, and that will be a eliminating the idle server cost and people those who want to manage the servers. So the next one is scalability. AWS Lambda functions are scales on demand. So it scales from 0 to millions of requests depending on the uh, request count you get. And third thing is fast development. You need to focus on only the business logic you are implementing, and no need to deploy it in any other server. It will take care of the other of the things from cloud provider. And next thing is simplified management. uh, as I mentioned earlier, it is no servers, no server provisioning and maintenance required. Then next thing is integration with other AWS services. Uh, this can be seamlessly integrate with various AWS services. If you have some background with AWS, there are many services they are providing. We can integrate AWS Lambda with S3, DynamoDB, and any. There are many. We will discuss in later of the section. And the event-driven architecture. This cause I have earlier introduced. Because of this, we can reduce the idle time cost. So it's only runs when event comes to the function. So this is basically about why we need AWS Lambda. Hope you all clear about it. Moving on. Let's talk about AWS Lambda core components. Give me a second. Yeah. In a AWS Lambda function, there are two main components. First one is event source and the Lambda function. What we call the event source is that is where provide a trigger to invoke the function. This is where the function is get invoked, right? So this illustration shows how AWS Lambda function works. In event source, it will send a request or event to the AWS Lambda function, and it will be process that data, and we can optionally send response to the event source. So this is basic behavior. If you want to extend this behavior to further, you can have a destination to the AWS Lambda function, because if you want to send some process result to let's say if you want to send some process result to another queue, you can move connect with AWS Lambda, that will be sent to the destination apart from sending the response to the event source. So let's see what are the event sources that we can use with Lambda function. I have listed down a few event sources here. Actually, there are a couple of more. I have added basic service we that often use. So first one is API gateway and S3. API gateway is a service AWS provide to manage APIs easily. So S3 is the storage service they are providing, and there's Alexa and CloudWatch, CloudFormation, SNS. Likewise, there are many services. So let's see what are the event destinations that we can use. Mainly, there are four types of four services we can use as a destination. Of course, we can use another Lambda function as the destination. We can call another lambda function inside of a lambda, another lambda function. So there is a SQS, which is a simple queue service provided by AWS, and there's a SNS and event bridge as well. Right. Another key thing I want to highlight it here is depending on the execution result, you can navigate to different destinations in AWS Lambda. Let's say if you want to, if the execution fails, you can redirect to the success queue, failure queue. If the execution passed, success, you can redirect to the success queue. Even another destination type also possible here. So, right. Let's write our first lambda function. There are some prerequisites for that. Uh, these are those. Right. You have to have a AWS account to write a lambda function, uh, and basic programming knowledge is needed. And I'll be using very basic example for the very minimal code of example to demonstration, and it will be advantage if you have familiarity with cloud concept. So because we are using other AWS services as well. So okay, moving on. This is what I'm going to demonstrate to you today. Let's create a serverless API with AWS Lambda and API gateway. I call it as optimistic word counter. I'll show you the code and you will understand why it is optimistic. Uh, to keep this code simple as much as possible, I use three to four lines function here, and it only uh, care of the happy part. It doesn't care about errors. Error handling is not here. That's why it called optimistic error handling. Let's have a closer look in the handler function. This function syntax might be different depending on the runtime environment you are choosing. So if it is Python, there's another code, but the basic concept is same. There must have a handler function. This is the entry point to your Lambda code, and process this handler function will process all the trigger uh, that function execution. So this receives a two argument. First one is event and context. Let's see what are those. First one is event. This contains all the information about the event. If it is a S3 post event, it will be uh, and another thing is content depend on the trigger source. If it is a S3 post event, the event object will be different. If it is a API gateway, the object will be different. So if you want, you can have some custom objects as well. We will see it in the demonstration. So second argument is context. This is optional. This actually has a guidance to the Lambda function with the execution environment and all. Oh, yeah, right. If I explain what I have written in here, it has a handler function. It is async function. It takes two parameters, event and context. Event is required here, but it won't use context in this function. In the third line, it will extract the paragraph from the event. The function is expecting paragraph to be there. So actually, I didn't add any error handling here uh, to keep this as simple. So, but it won't be same as in real world cases. So, and in the sixth line, I have added word counter. It will trim the string we are getting and split it to array and taking the length as the word count, and it will return the word count finally. So if I illustrate it in this way, user can make a request with a paragraph to it will text from the API gateway, and API gateway is responsible to send that into AWS function. So after that, it will return the word count as a response. So okay, let's code it in the AWS console. So hope you all can see the AWS console. This is, you can, if you haven't used this, you can just type AWS console and log in here. So in the first, after login to this page, you can search for AWS, search for Lambda, and service will be here. I'm already here. So this is the page where you are coming into after clicking on that link. So in this page also you can have a simple demonstration here. This is the node version of function. As I mentioned earlier, it has a handler function. It returns hello from Lambda as a string. So if I run this here, it will get a success message, and let's move to next section. This one is another demonstration for the Lambda, how Lambda works. Uh, if I click on any icon of mobile or camera, it will show us how Lambda function works. If I send more requests, you can see there are multiple instances getting initiated. Because Lambda is scaled out depending on the traffic, so it is not scaling up, actually it is scaled out. So this is the cost of the Lambda function. You will get, it has a pretty generous free tier, so it will be free for 10 million. There's a 1 million requests for free for a month. So let's create a function. You can create on the create function here. Right, you can create a function from scratch, or you can use a blueprint. If you select blueprint, it will be, there are some examples. You can choose your preferred language. I'm going for the create a one from a scratch. So let's call it as demo, and I'm using Node.json, Node version, because I'm familiar with that. If you wish to use another language, you can use there as well. Only difference is the syntax. So I'm using the Node 18 version, and I'll keep architecture as it is. And as the default execution role, we can keep this, create a new role with basic Lambda permission. So that will be enough for this demonstration. And I'll create a function. It takes some time to get created. Once it is done, you will be redirected to this page. This is the Lambda function page. You can write your own code here, and if you scroll down, it has generated a sample code here. So I have written the code previously. I'm using that. I'm just copying the code, and this is the code that I explained in the slide. I'm just pasting it here. And after coding is done, you can deploy your code. uh, in here there's a something miss because we have to have a trigger for the function. So first uh, deploy this right. After the deployment, you can it is successfully deployed now. You can test it with here. You can create a new event for a new test event. I'm writing a test as the event. It will be a private, and you can select any template from here. So this templates gives you the object event object based on the service. So if it is a API gateway, uh, the event object will be looks like this. So you can find the event object from here. There are many. If it is a CloudWatch event, the event object will be like this, and depending on your use case you can select. So I'm going to select the hello world one, and this won't be work for me because I'm expecting to be the paragraph object to be there. So let's open Postman, is copying and pasting it here. Right. You can save it. Either you can invoke it. I'm trying to invoke that function. Yeah. It returns a response is word count is 40. But we only did a test here. If you really want to invoke this in your browser or Postman, you have to integrate it with API gateway. There's another option called function URL. Uh, it is relatively new one. You can use that also. So for this one, I'm creating another API gateway for this. I'm moving to API gateway. You can, if it is not listed here, you can just search it and you can find the API gateway service. Yeah, there's a API gateway I have already created one. To show you, I can create. Let's create another one. It is pretty simple. Mm, you can click on the create API, and I'm going to build a REST API. So I'm clicking on build, and I'm going to start this also from scratch and use a new API, and we can give a name. Uh, demo. I'm going to use as word count API demo, and description is option. Endpoint type also I'm keeping as region. So I'm going to create the API. Right. Once it is created, you can create a resource. If you are familiar with REST architecture, we can create resource and expose different method. So here I'm going to create a resource called word count. So and creating a resource. Right. After creating a resource, you can add methods to that. Uh, Clicking on the add create method, and in here we can give the HTTP method. I'm going to use post. What this AWS API gateway does is when this resource get an post request, it will be call this lambda function. So I am selecting the lambda function, and I'm not using lambda proxy integration here. So I can select lambda here. So this is the counter demo. This is the function I have recently created. Selecting that and creating the method. Right. Word. Yeah, it's getting created. Right. Once it is successfully created, you will navigate to this page again. Now you can deploy API. So I'm going to deploy. When you go to the deploy, you can select the stage. Select a new stage and give in the new stage name as step. And clicking on the deploy. Yeah. Once you deploy that, you can get the invoke URL here. You can click it here and use that in your Postman. If you go back to the your Lambda function and you need to reload it, yeah, now you can see there's a API gateway as a trigger. So this is basically how you can add triggers to that. You can click on this button and add triggers as well. uh, let's call the API here, and you can paste that URL here and add the resource here at the end, and you can use the paragraph object and just make this short and trying to set. Yeah, it gives word count as 10. If you make that long, I'm undoing the changes and sending. Yeah, you can see the Lambda function is working and with the our API gateway. uh, that is a pretty simple demonstration, as you can get started with that. uh, okay, this is it for the demonstration. Now let's move to the key concepts about the AWS Lambda you have to know when you're using that service in production level. Right. These are the sorry. These are the essential concepts you must know about AWS Lambda. So first one is execution environment and life cycle. Let's see what is execution environment is. Execution is environment is a container that is isolated and secure place to execute your Lambda function. This manage all the resources required to run your function. So let's see about the life cycle. To uh, in order to provide cost effective scaling and all, it managing a life cycle here. First phase of the life cycle is init. The init phase has three sub phases. It will there's a extension in it and runtime in it and function in it. In this phase, the function will create or unfreeze the execution environment, and it will download your code. And if you have integrated with any layers, those will be downloaded in this phase and will be initialized the extensions as well. So another main thing is it will be initialize the code outside the main Lambda function, main handler. So the second phase is invoke. This is the phase actual business logic is running. Your main Lambda function will be invoked here. So there's another phase called shutdown. This will be shutting down the instance, but this doesn't happen event to event. But if the Lambda function doesn't get any request for a period of periodic period of time, it will shut down the function automatically. So again, when it is shut down, if it get any request, it will be again go the init and invoke phases. So based on this, you can see there are two types of starts that can be there in a invoking a function. So these are the four steps that we can divide the into life cycle. First one is start environment and download the code and initialize runtime. And third one is initialize packages and dependencies. This is where all the packages and your other libraries getting downloaded and initialized. Uh, Not downloaded, actually initialized. And fourth phase is the invoking phase. Uh, Actually, based on that, it can be a call a start, and we call it as call start and warm start. If the Lambda function is shut down, you are getting the request first time, it will be go for a call start. It has to be complete all the four steps to invoke your function. If the function is awake, which means recently it has get some request, it is up and already initialized, it will run instantly and it will be a warm start. So the another key things to highlight, I want to highlight is billing is will be calculated depending only for the warm start part. It won't be calculated for the initializing phases. Okay. After that, let's talk about some limitation about Lambda function. First one is memory. For a Lambda function, you can give 10 GB of maximum memory, and you can allocate RAM for that. CPU and other resources will be allocated depending on depending on the memory you have allocated. It is proportionate to the memory. So second thing is timeout. You can't run very lengthy process inside here. Maximum timeout value will be 900 seconds, which is 15 minutes. If you have some batch processing and really long stuff, this won't be a suitable uh, solution for your scenario. So, and if you can't use 15 minutes for every time, because it will wait until the timeout. You should avoid uh, giving much lengthy timeouts, otherwise you will be getting billed for that waiting time as well. The third one is concurrency. By default, it can handle one function. At concurrency is the number of invocations that Lambda can handle at a given time. Uh, if function invoke again, if the Lambda function while the process, it will be initiate another instance. So you can maximize that, but it will be cost again. So the next concept is AWS Lambda layers. So there's a way to share the common codes, so common packages between Lambda functions. We are using AWS layers for that. We can package and share supplementary code or data across the Lambda functions here. So what are the benefits of this is you can have preloaded layers in execution environment. So as I already mentioned, there's a cold start. We can reduce the cold start time if we have preloaded layers there, and it will be easier to for the deployment, because our deploying code will be less because we are already deployed all the shared function as a layer. So it supports versioning as well, and it promotes the code reusability, because you can use all the code across the another Lambda functions. So That's pretty much it for the today's session. If you have any question, you can share now. Right? You can edit as a comment. So yeah, if you are joining online, you can add it as a comment your question. So we will answer. Right. What are the questions? Yeah. To debug the lambda expression, actually, there are a couple of ways. In here, we did it in the AWS console. Actually, this is the not best practice to do that because let's go to the AWS console first. Right. I made a lambda function and then created a API gateway. These things are not get recorded. After another day, some developer comes and see. He doesn't know what are the configurations we have done. Of course, we can go to the one by one in here, but it is not practical. For that, we can use IAC, infrastructure as code solution. So if you want to debug this, and there are monitoring tools here, even in the console, or you can use SAM CLI, and SAM is where you can test your code locally before deploying it into the uh, any environment here. So if you want to debug some C logs in the AWS Lambda function, you can basically select the Lambda function, or you can directly go to the AWS Cloud Doge. Let's go to the domestic word counter here, and in here there's a monitoring section. Then you can click on the uh, Cloud Doge logs, and then I'm going to the login sites because we can check directly, filter out with the Lambda function name. So I'm going there, and here you can select the Lambda function you need to troubleshoot. Right, I'm selecting this one and running the query. I'm running this for last 1 hour. Let's see, are there any? Yeah, here it is. You can see the logs. If it is any error, it will be printed out here. So yeah, hope I answer your question. Any other questions? Since no other questions, so hope you have get something out of this session. Let's uh, wind up the event. Uh, Thank you for joining, those who are joining online. Thank you very much for joining our first session, and thank you all. Uh, if you have any suggestions or feedbacks, you can scan this QR. There will be a simple form. You can give your feedback. We really appreciate your feedback to our progress. So thank you very much.